An expression containing the AND operator or the OR operator is evaluated only until the truth or falsity is known. So therefore, with the AND operator, short circuiting takes place when the left side of the operand is false, right? The right side will never be evaluated if the left side is false. So we really don't care about this if this is false, because it will never meet the criteria. So the compiler or the program will just stop executing at that point and won't evaluate this half of it at all, right? For the OR operator, no, forgot I had a little stop sign there, nice. For the OR operator, short circuiting takes place when the left operand is true, right? So if this is true, we don't even care about the rest of it, because no matter what, true is true. And so with the OR operator, that's all we need. We just need one thing to be true. The right side will never be evaluated. So let's take a look at this code. And it calculates a basketball player's shooting percentage and prints an associated message. What happens when the code runs with the input of values of 0 and 0? Well, let's walk through the code. Okay, so we're going to put in 0 for attempted and 0 for made, right? If attempted is greater than 0, well, guess what? 0 is not greater than 0, and since we have the AND operator here, we don't care about this at all, right? It's just going to skip that and go to here, right? It's just going to print out, hey, practice your shot some more, right? What if made was 0, right? So say attempted was some value greater than 0. Say it was 5. We put in 5, right? And made was 0. Well, we're going to do the calculation here. Double made is 0. And so it's going to still do the math, right? If attempted was 0 and we didn't have this first, it would try to do a divide by 0, say, you know, and you can't have that. It'll give you a compiler error, right? Because both you have it here and you have it down here. That would give you another divide by 0 error. So you can't do that. So by putting this attempted greater than 0 first, we avoid that problem and making sure that we're not executing the rest of the code or trying to do some divide by 0 operation. Yep, and the builds are just going to tell you what I'm doing. And by the way, if you need to print a percentage sign in a print format and a printf, use the $%. So there you go. Now, an empty statement is a statement that does nothing. It consists of a semicolon by itself. And we use the empty statement in places where the compiler requires a statement, but there is no need to do anything. And this is pretty rare, but it does happen on occasion. For example, the for loop here can be used as a quote-unquote quick and dirty way to add a delay to your program. I don't recommend it. There's better ways to do it. But you could do this if you wanted to, right? For int I is 0, while I is less than 1 billion, increment I, right? So it's going to add a very, very short delay into your program because your computer is going to loop through this thing a billion times, right? So it might add a fraction of a second operand or delay to your program depending on how fast your computer is, right? So style guidelines stipulate that on the very rare occasion that you do need to do something like this, you put the semicolon on a line by itself, okay? Another place that you might see this crop up is in loop headers. Sometimes you've already declared a variable that you want to use again, and so you can put an empty statement inside the loop header because you don't need to actually declare anything, right? Maybe you have counter declared up here somewhere, but you want to use it for this loop, right? So you don't need to initialize the counter again in your loop heading. So you can just do an empty statement and just say, hey, you know what? We're not worried about this piece. All right. Empty statements can sometimes be useful, but they can also lead to cryptic code. So use them only if there is a good and valid reason to do so. And I've already seen this on plenty of students' homework assignments. So be aware that you can accidentally introduce an empty statement into a program. And you usually see this in a case like this, where you have a while loop, and you're going to put the empty statement right there on accident because you just put a semicolon after everything, right? Well, you don't put a semicolon after a while statement because it actually has to loop. So don't do this, right? Don't be bad, right? No semicolons after while loops. Now, you do put them after while loops if it's a do while loop, right? If we had do, right, do squiggly, and then a squiggly, then yes, you would use the semicolon. The break statement, when used inside of a loop, terminates the immediate enclosing loop and gives the control to the statement after the bottom of the loop. So as you can see in this code, right here we have a break statement, and so this will break out of the for loop. Okay, not the if, but it will break out of the for loop and resume right here. Okay, and if you think about it, it's the exact same behavior as what we have in a switch. But don't fall into the trap of using break statements too often. Usually someone reading your program will look only at the loop heading to figure out how the loop terminates, right? So they're going to be looking up in here to see how your loop terminates, and they may not be looking all the way through to this break statement. In using a break statement, you force the reader to look inside of the loop for the loop termination condition, and that makes your program harder to understand, bottom line. So in certain situations, a break statement does improve readability, but again, that's one of those things where it really depends on the use case, and you have to use them judiciously. Okay, I don't want to. You shouldn't be using breaks all the time to terminate for loops. Okay, it doesn't happen that often. There are certain cases where it does happen and it makes logical sense. Then feel free to do so. But if you can terminate your loop condition normally in the header, then you should do so. Okay, enumerated types. This is something that we haven't yet covered, and they're actually really useful. I remember studying this in my undergrad and going, man, I will never use enumerated types. It just doesn't make any sense to me. But they are really powerful, and they can really help clean up your code if you use them properly. So let's take a look at them. An enumerated type is a programmer-defined type that is used to restrict a variable to holding one of a fixed set of values as determined by the programmer. So suppose you are writing a program that needs to keep track of the day of the week, Sunday, Monday, Tuesday, etc. An elegant solution would be to define a day enumerated type for this, like this. Here you can see we are declaring public enum day, and we are passing in the values Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now we can use the enum wherever we need to have Sunday, Monday, Tuesday, Wednesday, Thursday, whatever, and we will restrict the input to just those values. So it's essentially a special kind of class with a public final member is what it is. Okay, so after day is defined, we can use it, we can declare it like this. We can say, hey, we have a day object called day, right? And we can get the property or the value of each day by calling day and then the constant. So if we want day to be equal to Friday, we call the class name, right? Not the object itself, but the actual class, and then the constant, right? So in this case, it's day.Friday. So remember, day up here is a special type of class because it's got the capital letter, right? And here we are calling the class .Friday. So now day is equal to Friday. So let's take a look at an example of a program that is using enumerated type for, to clean up the code. So here we have the grade management program, and it reads course percentages and calculates GPA. So typically in school we have grades, A through F or F through A, depending on your order. And so here we are declaring our class, our special enum class, up at the top, right? So you can see it's inside to grade management. So it's a private class. It can only be used by this grade management class right now. And then of course we have our main method, and we have here we are declaring our grade object called grade, right? And it's going to store one of these 5 values. And that's all it's going to do, right? So we're going to go and put into a do loop, and we're going to say grade equals get grade. Okay, so then let's jump down to the program where we get the grade. So here we have a scanner object, and we have a float percentage and another grade object, and we set it equal to null, which is nothing because it's a reference type, right? And so we ask the user to enter the overall course percentage or -1 to quit. And here we have a nested if block, which, you know, we could have done as a switch instead, right? If percentage is greater than or equal to 90, then grade equals grade.a. Do you see how we use the class name and then get the constant value that we want? Else grade is equal to grade.b, else grade is equal to grade.c, and so on and so forth. And then we return what the grade is. So we go back up to the main part of the program. So we've got our grade now based on what the user inputted. And we're making sure that the grade is not null because we're doing input validation, right? Remember, we don't like our users because they don't do smart things sometimes. I'm joking. So if case is equal to A, then we are going to add 4 points. If case is B, then we're going to add 3 points. And if it's C, 2, D1. Notice how we're able to use the grade as a switch mechanism, right? Grade is a enumerated type, and we can use it as a switch. So that's really handy, right? And we're going to repeat this all while grade is not equal to null. So once the user enters -1, guess what? Grade is null, right? Because we're not going to put in any percentages. And then we're going to return a null grade. Grade's going to be null. We're going to skip this block. And then we're going to print out the value. So if scores were equal to 0, then we'll print out no scores were entered. Otherwise, if we have some number of courses that was entered, then we're going to print out our overall GPA using our printf function, right? So we're going to print it out to 2 decimal places, right? Because we're specifying a float value with a precision of 2, right? Hopefully you remember that from first semester. Okay, and we're going to cast it as a float because we've got these values right here. Total points is a integer, right? And number of courses is an integer. So let's go ahead and run it and see what happens. All right, it compiles successfully, and we grab our program here. It says enter the overall course percentage. So if I want to do, I'm going to do 95, right? And I'm going to do 84. I'm going to do 72, maybe an 86. Maybe we got a smart, you know, person, or if maybe it's all for one person. Maybe they just did really well. 99. Maybe they bombed it. 25. And we'll do 33, right? And then we're going to enter -1 to quit. Oops. So there you can see our overall GPA was 2.29. Pretty cool. Worked as intended. So this is how you can use, and of course this is a trivial or novel application of it. You can use it for a lot of things. One of the biggest things that I see is people, they'll pass in integer values as a switch mechanism for a method. They will create a method and they'll say, well, if somebody passes in the integer value of 0, I want the method to do one thing. And if the user passes in the integer value of 3, I want it to do something else. And maybe they have a switch that will branch off and go execute other methods based on this, what's called a magic number. Magic numbers are terrible for code readability because once you start getting multiple ones in there, it can become really hard to follow your code. So that's another place where you can use an enumerated type because you can give those particular things names and values that are easy to read, and you can say, oh, if my method, if somebody's passing in this operation called, you know, cut versus paste, you can see what the intent is there to do. So that's another option you can do. It's also,
enumerated tapes are also useful for switches, right? As you can see here, we use the grade as our criteria for our cases. So enumerated types are very, very useful once you hunker down and get the hang of using them.
You can test enumerated types equality by using the equals equals and the not equals operator, like this. So here, if grade was equal to A, it's going to say, is A equal, is it equivalent to F? Well, no, it's not. So it's going to skip this block of code, right? And the cool thing is the computer pays attention to the order in which we list enumerated types of values. So values that are listed earlier are less than ones that are listed later. So in our day of the week example, Sunday was listed before Friday, so Sunday will be evaluated or considered less than Monday or Friday, right? So, but we can't use them. We can't use the less than or equal to or less than or equal to operators directly. First, we must have the enumerated constant call its ordinal method, which returns its position within the enumerated types declaration, where 0 is the first position. Whew! All right, what does that mean? All right, there's a lot of words in there. So let's demonstrate. If grade.ordinal or ordinal is less than grade C.ordinal, then do the following, right? Well, if you remember, we had F, D, C, B, A. You have to excuse me, I'm using my mouse instead of my pen to draw. So F, right, if our grade is less than, then it's going to say this is a prerequisite course, you must retake it, right? So basically it's saying you have to have a C or higher, or actually greater than a C to meet the criteria, right? So if you have a D or a F here, right, if this is an F or a D, then you're not going to be allowed to take the course because the ordinal value of F is 0. The ordinal value of D is 1. C is 2, B is 3, A is 4, right? So if you have less than a 2, then you are not going to be able to take the course because you didn't meet the criteria for passing the prerequisite, right? So F is equal to 0, D is equal to 1. Otherwise, if it's greater than or equal to C, you can take it, okay? So that's how the ordinal value method works. You just have to remember to call it as a method. You can't just say if grade is less than grade.c. And that's the whole point of this. We can also create enumerated types as classes. And it takes a little bit more work to set up, but it gives us some great functionality. So let's go ahead and take a look at that. An enumerated type is a class of pre-instantiated constant objects. So if we had a class we were working with that had an enumerated type declared, we can pull the enum declaration out of our class and put it into its own class, right? So we can take this enum and move it into its own class like this. The definition of an enumerated type can be in a separate file with a .java extension, just like any other class. And after compiling, its compiled form will be with a .class extension. Okay, so we can treat the enum just like a class. We create an enum class using the following steps. First, we list all the possible items that our enumerated type can be. For example, like we were making the day of the week before, this would be Monday, Tuesday, Wednesday, and so on, followed by the values that each enumerated type will represent in parentheses. Step 2 is we list the instance constants that will be associated with each enumerated item. In step 3, we provide a private constructor to build each enum item with. All right. Because the constructor is private, it cannot be called from outside of the enumerated type definition. So what calls this constructor then? Well, the items in step 1's list do. Each name in step 1's list and its corresponding parenthetical list of constants is a cryptic constructor call, right? The name is the name of the created object, and the values in parentheses after the name are the arguments that are passed into the constructor. Again, this is one of those things where when I'm reading it, it sounds really confusing. I get it. But don't be scared. It's really not that bad. We're going to take a look at some code, and it should make more sense after we look at the code. Okay? So here we go. We're going to break it down by steps, right? Step 1, provide a list of names for the objects with each of the names followed by a list of variables in parentheses, or a list of values in parentheses, right? So here you can see that we have our list of names for the objects: Parkville, Havana, Kingston, Nassau, St. Thomas, right? With each name followed by a list of values in parentheses. Here we have 39.2 and negative 94.7, and so on and so forth. Okay, that's not that confusing. Provide a list of names for the objects with each name followed by a list of values in parentheses. Right? Okay, step 1. Step 2, provide a list of instance constants that correspond to and will store each of the object's parenthetical list of values. So here you can see we have 1, 2 values, right? Well, look, we have 1, 2 variables to store those values. So the first one is probably going to be the lat, and the second one is probably going to be the longitude, right? Okay, not too bad. Step 3, provide a private constructor whose parameters correspond to the parenthetical list of values in step 1, and have that constructor use those values to initialize the instance constants in step 2. We've been doing this all along with our classes and creating constructors for those classes, right? Here we have, except for instead of being a public constructor, it's a private constructor, and it's only called inside the class declaration itself when we set up these things, right? So we have a list of properties. We have our constructor that's going to take those properties that we're going to pass in, right? So this value right here is going to get plugged into here. This value right here is going to get plugged into here. The constructor is going to take this value that's passed in and store it as a public member, right? It's going to take it and store it there. So that way, we now have access to those values by just calling the property, just so we can just call Parkville.latitude, right? Havana.longitude. And that's it. So it sounds worse than it is, but when you look at the code, it's really not that bad. It's just 3 steps, and you don't even necessarily have to do it in this order, right? You might want to think about, okay, what are the values or the properties that we're going to need, right? Well, we're going to need the latitude and the longitude. And so you build a constructor that's going to initialize those values, and then you come up with your list of things that you're going to want to definitively declare that these are the only cities that we are going to use in this program, right? And that's the key thing about this, is once you declare this, you're done.
So let's take a look at the city enumerated class in an actual program. So this is the same thing that we've covered already when we were walking through the steps, right? Step 1, declare this stuff. Step 2, set up our variables that are going to store the values. Step 3, we have our constructor that's going to build them. And of course, it's a private constructor, so we can't just make them willy-nilly. Finally, we have a main method here that will print out the values, so we just do that for testing. But then also you can see that we have this public method called getDistance, and where we pass in a city and we calculate the distance between the 2 cities using their latitude and longitude. Now, I'm not going to get into the math of how this works, right? Because this is not a math class. I'm not here to teach you trigonometry and how to calculate, the distance of a chord based on the sine and cosine and all that, right? All you need to know is that using this mathematical operation right here, we can calculate the distance between any 2 cities given its latitude and longitude. Okay, and then here we have a public method called print city values. So we have a main method which is just going to print the city values, and we come down here and print out the city values. So let's run this program. right? We're going to compile it, and we're going to run it. And you can see here that we print out all of the values for each city, Parkville, Lat, and Long, right? Which makes sense. Okay, nothing is all that exciting because we declared exactly what those variables were here. But here is our driver program that's going to actually use our driver, our driven class, right? Our enumerated type. And of course, you can see that this isn't very long at all. We have a final double, which is a conversion factor that converts kilometers to miles. We have a origin city, which we are calling Parkville because that's where the Park University campus is. And then we have a destination city of Kingston. And then we are going to call get distance to the destination on our origin object. So we are basically saying what is the distance from Parkville, right, to Kingston in kilometers, right? Or miles here. You can see down here in printf, we have our nice printf function, and we're going to run it. So let's run it and compile it, right? And you can see here that we have Parkville to Kingston is 2,922.1 kilometers or 1,815.7 miles. Pretty cool. So driver program, not all that big. Our enumerated type, it's really not that big either. The biggest thing is this method that we can add to our enumerated types to actually give them some functionality. Right? Since computers are binary and 16 is a simple power of 2, it's common practice to express computer quantities in base 2 or base 16, right? 2 to the 4th is equal to 16. So base 2 numbers are binary numbers, and base 16 numbers are called hexadecimal numbers. Binary numbers just use 2 symbols, 0 and 1, and base 16 numbers use 0 through 9, and then A through F. So we have 0 to 15. Okay? Sometimes you'll encounter base 8 numbers, which are called octal numbers, and they use 0 through 7. In Java code, if you want the computer to interpret your presentation of a number as something other than a decimal, you need to prefix it with the presentation of the number with a special quantifier. So for binary numbers, if you want to say a number is in binary, you preface it with 0b, either lower or uppercase, right? 0 or uppercase b. For a hexadecimal number, you use 0x or capital X, right? So often you'll see hexadecimal numbers used for memory locations and things like that. And so if you ever see 0x and then a location, well, that's what it's meaning. It means that this is a hexadecimal number, not a binary number. So we're going to take a look at a program that's going to give you an example of these concepts in use. Okay, so let's take a quick look at just a real simple program that I that I wrote up using the integer toString function and enums, right? So we just learned about those, so let's go ahead and tie them in. So here we have our public enum called convert, and we have binary, octal, decimal, hex, and we have our main method where we are going to print conversions of some numbers. So here they're all 345, but we can make it, you know, different numbers. Let's see, 2, 6, 7, 8. Let's put 2, 3, 4, 5, 6, 7. We'll make a really big number. Well, no, we'll make this one a big number. Anyway, so what this program does is it's going to just call this print conversion function, right, which is a static void because we don't need an instance of our class to run it. We can just run it. And so we are going to pass in a number and the type that we want to convert to. So we've declared up here binary, octal, decimal, hex, right? Convert binary, octal, decimal, hex. Now, what we want to do is we want to print out the corresponding conversion, right? So in the case of binary, we are going to print out the original value, and then we are going to convert it to binary. In this case, in octal, we're going to take in a integer value, and we're going to print it into octal, and so on and so forth. So if we run the program, all right, let's save it, compile, and run. here you can see, whoops, pull it back. Here you can see 345 in binary is 10110001, right? And 323 in octal is 503. And 2, 3, 4, 5, 6, 7, 8 in hex is 23 CACE, right? And of course, for the last one, no conversion is needed because it's already in decimal. So that's just a simple example showing you enumerated types and binary, hexadecimal, and octal numbers used in a program. And you can see here that we specified the base that we want to get the numbers in to a particular value, right? So we could also just say, well, hey, I just want to print out a binary value. So I could just do system .out.print. Let's print out, say, 0B 10010, something like that, right? Compile it, run it, and there you can see it printed out the integer value of what this value is, right? So here this is equal to 149 because it automatically is going to convert it to an integer, but we're telling the compiler that this is a binary number. This number is not 10,010,101. It is 149, right? So if we run this again, let's just change the order here, right? Just so you can see this running. If we change the order here and we print out 149, right, and we convert that to binary, and we run it, look at that. 149 in binary is 100100101, right? And if we print out 10, the same thing, we get the same response as expected. So if we put in octal, right, or if we put in hexadecimal 23 CACE, we could do the same thing. Let's just print out that value in hexadecimal, right? So instead of 0B, we're going to say 0x, and we're going to pass, what was the number again here? 2. All right, 23 CACE. So if we just say 23 CACE, we're going to compile it, we're going to run it. Here you can see that the number that we specified in hex is 23 CACE. And we print out 23 CACE, and we get the corresponding integer number.
So, like I said, this chapter was kind of a hodgepodge of different topics and techniques that don't entirely fit well into any other chapter. And some of these techniques you're probably not going to be using as often as some other things that we've discussed throughout the course. But it's definitely a good idea to understand them so you can read other people's code and improve the operation of your own code using some of these techniques. So I highly recommend you bookmark this section and go back in and reflect on it. Again, it's just a weird collection of stuff, but it is really useful utilities and things to think about as you're designing different programs.